Right. So in this video, we said we are going to talk about top K. Why do we even need top K? I mean, we saw that we can be more creative with temperature and just playing around with it. So why do we even need top K? Some who are taking this course would have noticed that with temperature, we sometimes generate nonsensical statements like every effort moves you pizza because it's just based on those probabilities and they don't make sense at all. So we introduced top K to try saying to be another way to introduce that creativity, but in a way that sort of makes a bit of sense. So if we combine top K with our multinomial, which is probabilistic sampling. So let me just write here top K. Our idea is we are going to combine this top K that we're going to discuss here, plus our probabilistic sampling, plus probabilistic sampling. Instead of using argmax, we use multinomial, plus our temperature scaling, plus our temperature scaling, plus our temperature scaling. We hope it can improve the text generation results. But what is this top K that we're talking about? That's what we are discussing now, right? So this top K, it restricts um, restricts the sample tokens, restrict the sample tokens to the top, as the name says, top K most likely, and excludes all other tokens from the selection process by masking their probability. So let's see how it does the masking. Let's just write here. Imagine we have this. Oh no, I increased by mistake my pen size. So let me take it down to like 2.7 should be fine. All right. So imagine we had this as our vocabulary. We had closer every effort forward because the vocabulary will be in alphabetical order, right? Forward inches, moves, and then pizza. Yeah, I'm running out of space. Toward, just imagine this is toward, and then the last one will be you. So that's our vocabulary here. So imagine this is toward, right? Toward and then you. That's our vocabulary. Let's say when we ran the model, these were the logics that we got back. So we got back 4.51 for closer, and then for every we'll get 0.89, and then effort. So even though they might not be aligned, just know that the logics are going to be in reference with the vocabulary, right? Because this position one, if position one is the answer, we then go to the vocabulary. We'll be like, what is in position one or index zero? Index zero is actually closer, then we'll get closer. So they should be aligned, but just because of space, I might not align them properly. But you get the indexes, right? 6.75, 1.63, minus 1.62, minus 1.89, and then 6.28, and finally 1.79, like that. Those are our logics. If we say we are selecting top K, let's imagine that we say we want to select the top three most likely. Which ones are we going to choose? So I do not want to rewrite everything. I'm just going to change the color. So if we're choosing the top three, we're definitely going to choose this one, and we're going to choose this one, and also we're going to choose this one. These are the top three most likely based on their logics, the values of their logics. Perfect. So now we've applied the top three. What then happens after that is we are going to put a mask and minus infinity mask. So everything that then is not part of that top three is masked by minus infinity, like this: minus infinity, minus infinity, minus infinity. Then this is 6.28, and then finally minus infinity. Why did we do this minus infinity? Some people can already tell why. It's because now when we are moving towards probabilities applying soft marks, the minus infinity will be affected. It will go to zero. It will go to zero. And now we will end up with our probabilities all adding up to 1, and the ones that are not, that were not in our top K, are then taken out of even consideration when we are sampling. They're taken out of commission. We do not have them anymore. You remember we did something similar in masked causal attention when we masked the top right corner of that weight matrix, and we masked it using minus infinity. Is the same principle that's applying here. So these top K, they were replaced. So those are going to be non-selected logits, and then everything goes on from there. We then say whatever it is, we then apply whatever we are going to apply after this. But let's see this in code. See this in code. So let's just quickly switch. So here we are using top K equal to 3. So we have our top logits and our top positions. We are using top K from torch, and we are putting our next token logits that came out of the model. It said, oh, these are the logits for the next prediction, next web prediction. That's what we're using there. And then here we're just applying our top K. Good. It's good that Torch already has these implemented. We're just calling them. So these are the top 3 logits, and they come back. They come back in descending order, as you can see. And so now we can also extract where they are happening. Where is their position? So this one happened at position 3, and this happened at position 7, and this happened at position 0 or index 0. So those are the indexes of where the top positions are happening. We can use this to say new logits. We can use this function called where, and the condition is very simple. It is like an if statement. So we are using it here just for it to be easy. So it is actually very, very simple. So what is the condition? The condition is equal to when then we anytime we get into the next token logits in that array, and it is less than these top logits, the last one, because they're in descending order, all right? So any predicted logit that is less than this that is less than this one, this minimum one in our top K, because of descending order, this becomes the last one becomes the minimum. That's why we're saying -1. So the minimum one in our top K. So any predicted logits by our model that is less than our minimum in our top K, replace it with this, and this becomes, or put this. So we are replacing it with minus infinity here. You see, we're replacing any any of these in this any in our next token logit. If it's less than our minimum, we are replacing it with infinity minus infinity, or the other we just say or keep it. So which means when we get to this token in our next token prediction logits, it will just keep it the way it is, but everything else is replaced by minus infinity. So these ones are kept safe. Cool. We could have done that by just saying exclude just these, because we know their positions. We could have done it that way without using the where condition. Could have done it either way. There's a much more efficient way to do it than this, but this is easier to understand, I would believe. So now our new logits are just going to be 451, because it is in here. It is not less than. It will say, okay, 451. Is it less than this 4510? No, it's not less than. Okay, so I'll keep it. The one that was here initially, the one that was there initially, it is less than this 451. So it is replaced by minus infinity and all of that. So that's what is just happening here. And then these are the new logits now. And we are going to calculate soft marks on them. And then we return these are the soft marks. Just like that. So now let's just quickly, I think in this same video, oh no, let me put it in the next video so that we know what we have packaged top K in its own video. In the next video, we're now going to modify the text generation to take into account all of these that we have just discussed. So stay tuned for that video.